Okay, you should have had a go at those questions at the bottom of the worksheet now. There were 11 of them altogether. Let's go through the answers. I'll draw as we write. So if I put that there, we should be able to see the screen, the paper. Okay, so the first one, describe his experiment. What he did was he fired alpha particles, lots of alpha particles, at a thin sheet of gold. Thin sheet of gold. And the gold, of course, is made of atoms, which we now know are almost hollow. So most of the alpha particles went straight through. The odd ones were deflected back like that. Question 2. What are atoms mostly made of? Space, right? Remember, the little dot in the middle there is absolutely tiny. There's something like Wembley Stadium would be this size, and that would be an orange on the middle of the football field. Okay, number 3. How many neutrons are there in this element? Well, we've got 23 and 11. This is sodium. So how many neutrons? That tells us the total number of particles in the nucleus. There are 23 altogether. 11 of them are protons. Okay, so that's N plus P. That's P. So it must be 23 take away 11 equals 12 neutrons. Next one. Number 4, suggest a different isotope of the above element, write it in the same format. Okay, so it's got to have the same number of protons, otherwise it wouldn't be sodium. So it's got 11 there, and let's say it's got 24. It's got an extra neutron, that one. Okay, 13 neutrons. Next one. You could have chosen anything, by the way. You could have chosen 21, 22, 25, 26, anything within that region. Explain why the word ionizing contains the letters ion. Well, as you know, an atom has a positive nucleus and electrons going around the outside there. When it loses one or more, or gains one or more of these electrons, we don't call it an atom anymore. It's not called an atom, it's called an ion. And anything that can make it change from an atom to an ion is called ionizing radiation. Number 5, explain why the word ion... Oh, I've just done that. Number 6, suggest why alpha radiation is more ionizing than beta. Because it has a greater charge. +2 is more than -1. Okay, it's the 2 and the 1 that are important, not the sign. Bigger charge, more ionizing, so it's more likely to knock an electron off or attract an electron away. Which one form of ionizing can pass through aluminium? That's gamma. Number 8, write the 3 radiations in order of mass, smallest first. Well, gamma is a wave, so there is no mass. Next most massive is beta, and then alpha is the biggest of all. That has 4, that has a tiny, tiny mass. Okay. Number 9, describe the wavelength of gamma rays in comparison to light. Well, remember, we've got the electromagnetic spectrum where the waves get longer and longer and longer, and in the middle here somewhere is light, then ultraviolet, then X-rays, and gamma rays are right at the end here, so they have very short wavelength, much, much shorter than light. Okay, and number 10, how many protons and neutrons does an alpha particle have? It has 2 protons and 2 neutrons. Number 11, for the above element, write down the new top and bottom numbers after an alpha decay. Okay, after an alpha decay, so we started with 23 and 11. Alpha decay, the top number comes down by 4 and the bottom number by 2. So we'd have 19 and 9. Okay, after a beta decay, we would have, that one would stay the same, so we'd have 23, but one of the neutrons turns into a proton, so we've got 12, so it would look like that after beta decay. And after gamma decay, it would look just the same as it did before. There's no change to those numbers. D, what proportion of radioactive nuclei remain in a sample after 4 half-lives? All right, let's look at this one. 4 half-lives. So to begin with, 1 half-life, it will have halved. At the end of that, we need to half it again, because it keeps halving. 2 half-lives, 3 half-lives, 4 half-lives. It's halving each time. 1, 2, 3. Hang on, that's the first. Sorry, that's not very good, is it? So from 1 to there to there. So it's halved, 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 which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is a 16th. There will be a 16th of the nuclei which are still active or radioactive. Okay, and those are the questions. You may want to go through this whole lesson a second time because we've covered an awful lot in it. So feel free to do that as many times as you need. You really do need to answer these questions fairly confidently. Okay, all the best.